Okay, so question 2, part A. For a given price P, which customers rent? Well, the utility a type theta gets from renting is theta minus P, and the utility they get from not renting is zero. So, naturally they'll rent only if theta minus P is greater than or equal to zero. Um, and so we get that type theta rents if that type is basically greater than equal to the given price P. Okay. For a given price P, what is the probability the customer rents the flat? So what we're looking for here is the probability that theta is greater than equal to P. And because we know that theta is uniformly distributed, it follows from the CDF of a uniform random variable that this is 1 minus P. Okay. Now we are asked to basically find all PBEs. So this is what we could call a reverse order PBE, in the sense that in this game, the uninformed player, the uninformed player is acting first, right? So Monica is acting first, um, and this is different, of course, from like say the labor signaling game where the informed player is acting first. That is to say, the workers who naturally know their own types. So Monica would basically have to first consider the customer strategy. So from the above, we know that a customer of type theta will basically rent if P is or basically rent if theta is greater than equal to P, and will not rent if theta is less than P. So with this in mind, Monica's expected utility from offering some P in 0, 1 is P times the probability that that particular customer is of a type which is greater than P, the probability of which we found in part B, which is 1 minus P. And so basically Monica will look to maximize this expression, and we'll basically find that this expression is maximized at P equals to a half. And so a PBE will basically be characterized by one, the customer strategy, and then the this P star equal to a half. So we'll say that our PBE, in our PBE, Monica sets P star equals to a half, and types greater than equal to half, except, or rather, rent, and types less than half do not. Okay. Okay. Mm. Now it's useful to mention here that, say, you know, P was not restricted to 0 1, and it was like, it could be any positive real number. Well, in this case, what uh, what would um, uh, Monica's um, optimal PB? Well, she knows that, the highest price, that she can offer, while still, ensuring that the customer accepts, is a price which is equal to theta. Now, of course, theta is in 0 1, so she's not going to offer anything outside of this range. um, and so, P will be, um, the domain of P will be restricted from all possible positive real numbers to 0 1, and we would basically have the same problem. So Monica would look to max, um, and this is in 0 1. Okay. But in this case, the problem sometimes made it easier for us because it restricted P to 0 1, so we didn't have to notice that, we have to shrink the domain of P from R plus to 0 1. So part D, find all prices that occur in a pooling PBE. Okay, so we can follow the same 5 steps as we did, in the case, as we usually do in the case of PBEs. In particular, those 5 steps we used to solve the signaling, labor market signaling game. But we'll see that there's sort of an added complication here, basically because of the theta term in these utility functions. But we'll get to that. Okay, so final prices that can occur in a pooling PBE. Well, we first know that, so we first, again, we specify the uninformed player's strategy. So a Monica strategy in any pooling PBE. Well, obviously the price which the low quality flat is posted is going to be equal to the price for which the high quality flat is posted, and that's equal to some P star. Now we have to derive the corresponding belief system, that is to say, the beliefs of the customers, right? So beta 1 is equal to the probability that flat is low quality given P star. And again, because as in the case of labor signaling, if both flats are posted at the same price, then the posted price is not going to reveal any information about the quality of the flat, and so this conditional probability is just going to be equal to the unconditional probability that the flat that any flat is of a low quality, and this we know, this we're told is half. Okay. Then beta 2 we'll define similarly as the probability that the flat is high quality given P star, and that is just equal to the unconditional probability that the flat is of a high quality. That is half as well. So third, we identify the informed player's best response to these beliefs, right? So we want to sort of identify that given these beliefs that we've ascribed to the customer, what is their optimal strategy. Okay, so say some P star is posted, right? So the customer's expected utility will then be the expectation of um, will be theta plus the expectation of Q given P star subtract P star. So this expectation is of course so with probability half it's low quality, 0 with and with probability half it's high quality, quality 1. So this just becomes half subtract P star. So then what is the optimal strategy of this of the continuum of customers, that is to say which customers will rent and which customers will not rent? Well, this expression is greater than equal to 0 for P star less than equal to theta plus a half. Okay, so that means we can identify a best response strategy for the customers as a function of theta and P star, which is basically to rent if so this is not the relevant rearrangement. Okay. So okay, that's better. So rent if your type is greater than equal to P star subtract half, and do not if your type is less than this. Okay, so now having specified the customer's best response to their beliefs, we have to check for the range of P stars which are consistent with the PBE, which is to say the range of P star which precludes any deviation on the part of Monica. And so the first step to doing this is, so more concretely what we're looking for, what we're trying to make sure is that Monica will not want to offer some price not equal to P star for either flat. So in order to do this, we need to calculate utility she gets from offering the low quality flat, okay, at P star, and then the utility she gets from offering the high quality flat at P star, and then the utility she gets from offering the low at some P not equal to P star, and the utility she gets from offering some H from offering the high quality flat at some P not equal to P star. Okay, and then we'll have to we'll get inequalities, and then hopefully we'll be able to derive levels of P star which ensure that this is higher, so this is higher than this, and this is greater than this, right? So that is what we are going to do. Okay. So utility that she gets from posting the low quality flat at P star. Well, this is obviously an expectation, right? Because, right, so she gets, so say she has low quality flat, she's offering it a P star, right? So now if the customer accepts, she's going to get P star, right? But which type of customers accept, right? It's only customers with the type greater than P star minus half. Okay, so this has to be multiplied by the probability. This has to be multiplied by the probability that theta is greater than or equal to P star minus half. Okay. And this is exactly the same expression, because her utility she has the same utility function in the case of the low quality flat and the high quality flat. Her utility function is always just P. So okay, now we have to identify off-path payoffs for Monica. But again, in order to do this, as we did, as was the case in the labor market signaling game, we have to specify what customers believe about the quality of a flat which is posted at some price which is different from P star. And again, we want to make this belief such that Monica gets as low a utility as possible by deviating to some P not equal to P star, right? So let's say that we have beta 3, and let's say that the probability that the customer places on a flat being a low quality flat given some P not equal to, some P prime not equal to P star. Let's say this is 1. Okay. So this will ensure that Mary gets the lowest off-path utility as possible, because of course customers will be less willing to accept a high price for a low quality flat. So if this is the case, then off path Mary will get this P prime. Well, okay, before we do that, we have to determine the customer's best response to P star, right? So if they see some P star posted, what are they going to do? Because we have to determine what they're going to do before we can specify Mary's utility, off-path utility. So the best response of the customer, the function of theta and P prime, would basically be to rent if, well, what is their utility, right? So the expected utility if they see a P prime is just going to be, right, if they rented a P prime, the expected utility is going to be, right, but the Q disappears because they know with probability 1, they believe with probability 1 that the corresponding flat is a low quality flat. So that means they're going to rent if theta is greater than or equal to P, and they will not if theta is less than P. So this means that Mary's expected utility from deviating to P prime is going to be P prime times the probability that the customer accepts, which is the probability that theta is greater than P, which is of course just 1 minus P prime. actually more properly. Okay. So P prime times the probability that theta is greater than or equal to P prime. And it's the same for this case. Okay. So this probability, so in working out these probabilities, we have to be a little careful. So, okay, so so here we have, so in this case, so let's first start with this case actually. Okay. So we have two cases. We have two cases to consider, right? Either P star is less than half or it's greater than half. Okay. So let's write this again. So we have, so and we'll just, because it's the same in both cases, so we just have to consider in one case. Right, so we have two cases. Either P star is less than half, because again this is a CDF, so we sort of have to be careful with how we go about things. Okay, now if it's less than if it's less than or equal to half, well, in that case, the probability that theta is greater than or equal to some negative number or 0 is just going to be 1, right? So we have that this term reduces to 1, so we have, right, so the utility in that case would just be P star. Expected utility would just be P star. We have another case, however, where P star is greater than half. In that case, but it's greater than, it's greater than half, but it's less than 1, obviously. So in that case, we would have P star, and then this expression would just be a well-defined CDF, and we get 1 minus. Okay, so we have two cases we need to check. Okay, what about the deviation utility? Okay, let's check now the deviation utility. Okay, the deviation utility is P prime times the probability okay. In this case, in the case of this expression, there's only one case to check, right? Because P star cannot be less than 0, right? Because it's constrained to 0, 1. So we only have the case where P star is between 0 and 1. In which case this is a nice, well-defined CDF. And so we have that P stars. Okay. Now again, as we did in the labor signaling game, we have to consider Monica's optimal deviation, right? So if this is what she's getting off path, then she wants to obviously maximize it, and she's going to maximize it by setting P star equals to a half. Okay, that means off path utility is going to be equal to 1 over 4. Okay, so right, because we consider, what does the customer do when they see some p star p prime which is not equal to p star, right? Okay, so we said that they believe that the flat is low quality type, with property 1 that the flat is of low quality, and so then they behave in in this manner. Now if they behave in this manner, then that means that Mary's expected utility from offering p prime, that is to say from deviating, is equal to this, which we said is equivalent to this. And then of course she wants to maximize that off path utility. She does that by doing this. Okay, so finally then we're in a position to check for the levels of p star which we can have in a pooling PB. So we have to consider both of these cases. Okay, so if p star is, so just to recap what we're trying to do, we're trying to find p stars consists such that what she gets on path, which is p star times the probability that theta is greater than equal to p star minus half, is greater than equal to what she gets off path, which we have determined here is 1 over 4. Okay, but again there are two cases to consider, right? This expression will differ depending on the level of p star, right? Because in particular, because this expression is the CDF, right? So we have to be alert to this fact. So we have case 1, and this will be very redundant, but it's good as a general method of practice. So case 1, p star, well, actually, to make this a bit more concrete, we'll set it out like this. Okay. Okay, so we know that this expression, this is basically a CDF, and this is going to equal to 1 if p star is less than equal to half, and it will equal to 3 over 2 subtract p star if p star is greater than half. Okay, so we have to consider both of these cases. So case 1, where p star is less than equal to half, we have that this inequality reduces to p star greater than equal to 1 over 4, and then that is a condition we have in p star, right? So we've in each case we have to consider the conditions on the constraints on p star such that this holds, and then that will give us the final set of constraints. And then when answering the question, we have to pay attention to the constraints which are on p star, which are derived in either case. Okay, so we have, okay, so that was correct. So case 2 is where p star is greater than half. So in this case we have that p star, so we want this to be greater than equal to 1 over 4. But now if we look at this carefully, and we can graph it also if you want, we'll find that actually this holds for all p star greater than half. So actually in this case we don't have any constraints on p star, and so the only constraint on P star we are getting is that found in case 1. Okay, so this holds for, and so then the final answer is simply that P star might possibly be anywhere from 1/4 to 1. Okay. It's any price in that range is a price that we might encounter in a pooling PBE. And again, from case 2 we derive no constraints on P star, just because this holds for all P star greater than half. Okay. Now part E, we are asked to find all price pairs that can occur in a separating PBE.